Hi friends, I'm back again after 2 days to continue with the video of linear programming problems. Uh, Many comments have been uploaded to teach in Hindi along with English because a lot of students they feel easy mm, to understand in Hindi than in English. So well, as I'm not so comfortable with the Hindi language, I usually use English, but in this video I shall use both the languages, both Hindi and English, for the sake of my viewers and my well-wishers. Anyway, I had explained uh, about LPP, what is the concept of LPP, about optimization of a problem. Now, in this video, I plan to explain few problems with uh, examples which will surely help you to solve the problems of LPP. Let us continue with the video to see the example. Let us see this example where we have maximized z is equal to 3x plus 2y, and these are the restrictions: x plus 2y less than equal to 10 and 3x plus y less than equal to 15. X greater than equal to 0, y greater than equal to 0. X greater than equal to 0 and y greater than equal to 0, they are known as the non-negativity constraints. Now, as I have told you earlier in the video, x plus 2y less than equal to 10, this inequality, let us consider it to be a equation. X plus 2y equal to 10. If I consider this as an equation, this becomes the equation of a straight line. So if I write y equal to minus x plus 10, dividing both sides by 2, coefficient of y is 2, we get y is equal to minus 1 by 2x plus 5. Now taking x and y values in order to plot the graph of this line, when x is 0, y is 5. When x is 4, y is 3. When x is 6, 6 by 2, 3. So y will be 2. So we get a set of points for which we can draw the line on a graph paper. Same thing, let us consider the other one. This is the first one. 3x plus y equal to 15, or y equal to minus 3x plus 15. Same way, taking x and y values, when x is 0, let us take x 5, let us not take very big values, 5, then y will be 0. When x is say 3, then y will be 6. When x is 4, then y is 3. So we have got for equation 1 and 2 a set of values for which we can plot the graph. X greater than equal to 0, that means x is equal to 0 represents y-axis, and y greater than equal to 0, or let it be equal to 0, that it represents x-axis. So we have four equations, 1, 2, 3, 4. All the four we shall plot on a graph paper in order to see its behavior, and accordingly we shall shade and find out the solution region or the feasible region. Already I have marked the graph paper, the y-axis and x-axis for our convenience, so that I can show you easily. See, on along x-axis I have taken 2 centimeters is equal to 1 unit, and along y-axis I have taken 2 centimeters is equal to 1 unit. So let us plot the first line. We have got points 0, 5, 4, 3, 6, 2. Zero 5 will be here. Then we have 4, 3. 4, 3. Let us take it here. And next point is 6, 2. 6, 2 is somewhere here. So let us draw the line. This represents the first line, x plus 2y less than equal to 10. We shall shade the portion. Actually this is x plus 2y equal to 10, but after shading this will show the inequality. So let us write equal to, because it is the straight line. Then we have the next set of points, that is 5, 0. And then 3, 6. And 4, 3. So we have got the lines on the straight, on a straight path, that is this way. So this represents 3x plus y equal to 15. 3x plus y equal to 15. Now x y equal to 0 and x is equal to 0 are the x-axis and the y-axis on the positive sides that we have already mentioned. Now we have to shade the line according to the feasibility. First equation is x plus 2y less than equal to 10. If I put a point on the, taking any point on any side of the line, if I take 0, 0, then 0, 0 if I put here, 0 plus 2 into 0, that will be obviously less than equal to 10. If it is less than equal to 10, that is a true statement. So we shall shade it towards the origin in this way. If it was not a true statement, we would have shaded the other side. Same thing this for this line. If I put 0, 0 here, then 0 plus 0 y 0 will be less than equal to 15. That is also towards the origin. So the common portion which I get is this portion. I am getting this portion as the common portion. So if I name the corner points, here it is 0, so 0 0, then I have 0 5, here it is 4 3, and here it is 5 0. O A B C. So let us find out which one is the maximum value. So we have got points O 0 0, then we have A 0 5, then we have B 4 3, and C, that is 5 0. Corresponding to that, Z we have, Z is, so Z, let us write here, Z is equal to 3x plus 2y. So Z is equal to, we will put 0 and 0 here, so that is 0 plus 0, that is 0. Then again we put here x0 and y5. So Z is equal to 0 plus 5 2s are 10. So 10. Here Z is equal to 3 into 4. X is 4. Y is 3. 2 into 3. That is 12 plus 6. 18. And next finally we have C50. Z is equal to 3 into 5 plus 2 into 0. So 15. So what we have noticed, we have got 4 points, 4 values, 4, 0, 10, 18 and 15. So among them 18 is the maximum value. So Z attains maximum at x is equal to 4 and y is equal to 3. So this is the solution of the given inequation. I suppose you have understood. Let me tell you one thing, that is I have used the pen for explaining you the graph, as in the video if I use pencil it will not be so clear. So I have used the pen, but it is my request as well as suggestion that you please use pencil, so that if there is any mistake then you could rectify your mistake by rubbing or and it is very neat and clean. Thank you. Let's go for the next example. Let us see the next example. A diet for a sick person must contain at least 4000 units of vitamins, 50 units of minerals and 1400 units of calories. So these are the three things a sick person's diet should contain: vitamins, minerals and calories. There are two types of foods, two foods A and B, available at a cost of rupees 4 and rupees 3 per unit respectively. That means rupees 4 is the cost per unit of food A and rupees 3 per unit is the cost of food B. If 1 unit of food A contains 200 units of vitamins, 1 unit of mineral and 40 units of calories, and 1 unit of food B contains 100 units of vitamins, 2 units of minerals and 40 units of calories. These are the compositions food A and food B should have of vitamin, minerals and calories. Then what combination of food should be used to have the least cost? Means what should be the combination of foods that means how much of units of food A and how much units of food B should be mixed, so that the diet for the person is
at the least cost. So this is a problem of minimization. So let us first make a rough outline of the problem. That is, first of all, we have to minimize. Minimize z. So first of all, let us write x be the units of A used and y be the units of B. Then z should be, if one unit cost is rupees 4 for food A and rupees 3 is the cost per unit of food B, then minimize z should be 4x plus 3y. 4x plus 3y. Now what are the restrictions? Restrictions are, let us write here, vitamins, then we have minerals, and next we have calories. If I write here A and here B, then 200 units of vitamins, 1 unit of minerals, and 40 units of calories. And another B has 100 units of vitamins, we have 2 units of minerals and 40 units of calories. But we have, if the food should have at least 4,000 units of vitamins. This is the minimum requirement. And 50 units of minerals and 1400 units of calories. These are the restrictions of vitamins, minerals and calories. So what are the non-negative, what are the constraints? We have 200x of A and 100 units of vitamins for B. That should be greater than equal to 4,000. Means he can have more than 4,000 units of vitamins, and after reduction or after simplifying we will get 2x plus y greater than equal to 40. This is first restriction or first constraint. Next, similarly, x plus 2y, that is greater than equal to 52, and finally 40x plus 40y will be greater than equal to 1400, or that is equal to x plus y greater than equal to 35. And finally we have the non-negativity constraints, that is x greater than equal to 0, y greater than equal to 0. These are the constraints. Based on this, we are supposed to draw the graph. Let us take the first inequation, x plus 2y or 2x plus y. 2x plus y is equal to 40, or y equal to 40 minus 2x. We can take 2 points and draw the graph also. X, y. If I take x is equal to 10, then y is 20. X is equal to 20 if I take, then y is 0 and x is equal to 15 if I take, then 15 to the 30, 40 minus 30, that is 10. These 3 points I've got. For the next one, x plus 2y equal to 50. You can see the second equation. For that, if we write as a subject of x, 50 minus 2y. If y is 0, x is 50. If y is 25 to the 50, so x is 0. And one more, if I take y say 10, then x is 30. Finally, x plus y equal to 35. X plus y equal to 35, or y equal to 35 minus x. X, y. So, if x is 0, y is 35. If x is 15, then 35 minus 15, that is 20. If we take x is equal to 10, then 35 minus 10 is 25. So we have got all the three set of values for plotting the graph. So let us take the graph paper. I have already marked for our convenience along x-axis. I have taken 1 centimeter is equal to 5 units, 5, 10, 15, 20, that I have taken up to 55, and this side also along y-axis 5, 10, 15, 1 centimeter is equal to 5 units. Now let us take the first point, that is 10, 20. Then we have 20, 0. Then we have 15, 10. 3 points we have got. Joining the line and writing here the equation of the line, that is 2x plus y equal to 40. 2x plus y equal to 40. Next we have 50, 0. 50, 0 is here. 50, 0. Next we have 0, 25. And final point is 30, 10. Joining the line. And the last one is 0, 35. 0, 35 is here. 20, 15. And 25, 10. So these are the 3 points, 1, 2, 3. So joining it, we have to see that whether they are in the straight line. If it does not come in the straight line, that means the plotting of the graph according to the points are not perfect. So this is representing the equation x plus y equal to 35. And the previous one we have missed, x plus 2y equal to 50. X plus 2y equal to 50. Now looking at the equation, let us come to the previous one. If I put the values of x and y 0, 0, you'll get 0 plus 0 greater than equal to 40. 0 plus 0 greater than equal to 40, that is a wrong statement. So we will shade it away from the origin. We will shade away from the origin for the first equation here. So we will get it here somewhere. And next we have x plus 2y greater than equal to 50. So here also if I put 0, 0 greater than equal to 50, 0 plus is not greater than equal to 50. It is a wrong statement. Here also we will shade it away from the straight line, away from the origin. Same condition is for the third one. So this is the place where we shade, and we have got the unbounded region. Here previous example what we saw, that was a bounded region which we got the feasible region. Here it is a unbounded region. It is a unbounded region. So there was a difference between the previous question and this question. We had got a bounded region in the previous example. Here it is a unbounded. So these are the corner points that we have got: 1, 2, 3 and 4. The first corner point is A, let it be. Here B, this is C, and this is D. This is the common portion that is shaded. So we will write the values. A is 0, 50. B is 20, 15. C equal to, it is 5, 35. And D is equal to 0, 40. So we have got the corner points. Now we shall plot them. We shall place the values in the optimization equation, that is z equal to 4x plus 3y. So for A 0, 50, z is what? Z is 0 plus 3 into 50, that is equal to 150. B 20, 15, so z is equal to 4 into 20 plus 3 into 15, 80 plus, that is 5, 125. C 5, 35. Z is 530 actually. It is 530. It should be 530. In the graph if you see, it is 530 and not 35, 530. So we get 4 into 5, 20, 30 into 3, that is 90. So that is 110. And finally D is 0, 40. So Z is equal to 0, 40. plus 120, that is 120. Just a minute, I'm sorry, this is 50 0, not 0 50. This is 50 0 because it is on the x-axis. So 50 0 if it is, then the value becomes the value of z. A I am calculating once again. A 50 0, that is equal to z is 4 into 50 plus 0, that is 200. Now what we notice is these are the values: 125, 110, 120, 200. Among them 110 is the least value. 110 is the least value, rest other values are greater. So z is minimum at x is equal to 5 and y is equal to 30. So these are the values of x and y which satisfies the constraints as well as the optimization condition. I think by this we have understood about how to solve a linear programming problem, both maximization as well as minimization. When it is a statement problem, you are supposed to construct the inequalities and accordingly put the values. Thank you and meet you again.